Hey guys, so for your starter today, again, I want you to do these review questions. You'll see them again, I promise. And for this morning, I wanted you to do number 5, 6, and 7. Question number 5 was one that not a lot of you, but certainly several of you missed when you took this as a benchmark. So let's look at this. A solid block is attached to a spring that is mounted to a table. And what we think bothered a lot of you is this idea of having the block on a spring. A force causes the block spring system to vibrate up and down for a few seconds before it comes to rest. So let's just stop and think about that. If it's at rest, it's not moving. If it is at rest, it's not moving. And before we go any further, let's review. If something is not moving, then that means that the forces on it are balanced. We also know that if something is moving at a constant speed, it's not speeding up, it's not slowing down, and if it's not changing direction, the forces on that object are also balanced. The only way that we get things to speed up, slow down, or change direction is to have unbalanced forces. So before I read these answer choices, it says which statement correctly explains if the forces are balanced or unbalanced. If it's at rest and not moving, they're balanced. All right, so that means when I look at these answer choices, I can automatically get rid of C and D. They both start out with the forces are unbalanced. The forces are unbalanced. I don't have to worry about those at all. It has to be A or B. The forces are balanced because the block and spring are in a steady position and not moving. The forces are balanced because only balanced forces can create up and down vibrations in a spring. So the correct answer is A. They're balanced because the block and spring are not moving. Right, for number 6, a car is accelerating forward on a road. The arrows in the image represent 4 different forces. All right, so this looks like my free body diagrams that we practice. X, Z, W, Y. Which forces are equal and why? All right, first of all, if the car is accelerating, speeding up, I can't have balanced forces. They have to be unbalanced. And so I assume that in order for this, I'm going to say it's going this direction, speeding up to the right. Then I know that force Y must be bigger than force W so that the car accelerates. I'm going to have it accelerating to the right, not backing up. So it's moving to the right. I know that force Z is the force of gravity pulling down, but the car's not falling down through the ground. And so I know that I also have the normal force, force X, that's the ground supporting the car itself. So which ones are equal? All right, W and Y, because the car's moving forward? No, I know those are not equal. They can't be because the car's moving. It's unbalanced. W and Z, because the car resists gravity. I don't know. If they're balanced, they've got to be in equal and opposite direction. Well, those are not opposite direction. X and Y, nope. Forces X and Z, the car remains on the ground. Sure, the car's not floating and it's also not crashing into the ground. So the correct answer is D. The normal force and the force of gravity are balanced, are equal and opposite. And then number 7, a student slides 2 magnets onto a stick. One magnet sits at the bottom and the student holds the other at the top. So the student is holding this one up. Next, the student releases the magnet at the top and observes that it does not touch the other magnet. So the student, is maybe holding this, lets it go, and it goes down, but not all the way. Which explanation describes the forces acting on the top magnet after it's released? All right, well, I know one thing. I know gravity's pulling it down, But since it doesn't come all the way down, I have to use my knowledge of magnetism. I know that I probably have two like magnetic poles here, maybe a north pole and a north pole, and they're repelling, and that's working opposite of gravity. So I think gravity is trying to pull it down, but the magnetism is pushing it up. So let's see. The gravitational magnetic forces both repel the magnet. No, gravity is always going to attract. Ooh, look down here. A gravitational force attracts the magnet, but a magnetic force repels the magnet. There we go. It's D, because I know that gravity always attracts. It's a one-way force, and the answer is D.